Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to do the PYQs of the chapter Redox reaction. Okay, so we'll be discussing top 30 questions. So now if you check from the last 10 years, okay, we will find it's a very low weightage topic. So you could just find 10 questions in the last 10 years in the KCET. So I have included Comet K previous year questions as well in this section. Okay, so now let's get started, and one more request, please join our WhatsApp channel. Link is there in the description section, so you can join there and get access to all our PDF notes. Okay, fine. Now coming to this one. Okay, which of the following is not true for oxidation? So if you remember oxidation definition, we have discussed addition of oxidation is oxidation, addition of an electronegative element is also oxidation, removal of hydrogen is also oxidation, but removal of an electronegative element is reduction. So option number D is the correct answer here. Next question is about oxidation number. What is the oxidation number of S in H2S2O8? Okay, so now if I want to calculate, or if you want to see the structure of H2S2O8, it is like this. Okay, you should know this structure to solve this question. Okay, so now if I want to calculate, so you can see, let us take H oxidation state is +1, so 2 into +1. Okay, then I have S2, so that means 2 into X plus. Now you see oxygen, there are 6 oxygen which is having an oxidation state of -2. So it is 6 into -2. Okay, and then we have 2 oxygens, the charge is here -1 because it is a peroxide linkage. So 2 into -1. Okay, that is equal to 0. So I'll get 2 plus 2x minus 12 minus 2 is equal to 0. So we'll have -14 plus 2 minus 12, so x will be equal to 6 here. Okay, so if you do not know that this is an peroxide linkage, and if you calculate, it will come, the answer will be different and will be wrong. Okay, so you have to be very careful here about the structure. Next question, in which of the following the compounds of an element exhibit 2 different oxidation state? So that you know NH4 and NO3. So if you see, this compound is like this, NH4 plus and NO3 minus, right? So what is the oxidation state of nitrogen? X plus 4 is equal to +1, so X is equal to -3. Okay, so here X is -3, and if I see in NO3 minus, okay, so X, and here we have -6 and here we have -1, so X is equal to +5. Okay, so in the same compound the nitrogen has 2 different oxidation states, so option number D is the correct answer here. Next, the oxidation number of nitrogen in NH4NO3 is, you can see similar question just now we solved, it is 3 and -5, so that is -3 and +5. Option number A is the correct answer. You have to be very careful with the options. You can see that the charges have been reversed. Okay, next, the oxidation number of sulfur in Fe, sulfur in is -1 in. So if I see this structure FeS, okay, so you know iron is +2, that means sulfur in this is -2, and if I see FeS2, so if I calculate Fe is +2, okay, and here I have 2x, that is equal to 0, so x will be equal to -1. So correct answer is option number B here. Next, the oxidation number of Xe in the given compound. So we know barium belongs to group 2 elements, right? Beryllium, magnesium, calcium, barium and radium. So barium has +2 oxidation state, so 2 into +2. Okay, next Xe is 0, then we have 6 into -2, that is equal to 0. So we have -12 and +2, so -4, x is equal to +8. Right? The correct answer for this question is option number A. Next, what is the oxidation state of phosphorus in the following compounds? Okay, so first we'll find for H3PO2. Okay, H3PO2 is in H3PO2, so it is 3 plus x plus -4 is equal to 0, so it will be equal to +1, right? +1, so we can eliminate option number B. Next, if I see here, we can see the difference. So if I just calculate this one, I will be able to find the answer for H3PO4. Okay, so this is 3 into plus 1, then plus x, then I have 4 into minus 2. So if you see minus 8 plus 3 minus 5, so x is equal to plus 5. Okay, the correct answer for this question will be option number D. Next, oxidation number of bromine in Br3O8 is. So if I have Br3O8, okay, so here if I see it, the 3x for bromine, then 8 into minus 2 is equal to 0, right? So we will get 3x is equal to plus 16 and x is equal to 16 by 3. Okay, correct answer is option number D here. Next, in which of the following cases a chemical reaction is possible? Okay, so now if you see AgNO3 solution is stirred in copper spoon. So if you have like this a solution of AgNO3, okay, and a spoon of copper, right? So now what happens, the copper is more reactive than silver, so copper can replace this one, okay, and we can get copper nitrate and a chemical reaction can take place here. Okay. Next, concentrated HNO3 is stored in a platinum vessel. We know platinum is a very less reactive element, okay, very inert element, so there is no reaction here. Gold ornaments are also least reactive elements. ZnSO4 is placed in copper vessel. So you have copper here, vessel is made up of copper and ZnSO4 is stored here. And we know that copper cannot replace the zinc, right? So that is why this is also not there. Clear? Next, question number 10, the oxidation state of potassium in KO2 is. Okay, so if you see KO2, okay, so oxidation number of potassium, so we can calculate this one is like okay, x plus minus 4. Okay, one thing we should know here, okay, the structure, okay, one second. Next question, the oxidation state of potassium in KO2. So here you should know that KO2, sorry, one second, yeah. So KO2 is a superoxide, okay. In superoxide, the oxidation charge, if you remember, it is K into K plus minus half plus minus half, okay, is equal to 0. So now the charge will be plus 1. Option number C is the correct answer here. Next, a metal M plus 3 loses 3 electrons, its oxidation number will be. Now see, already it is in plus 3 state. Now if it loses 3 electrons, so another 6 charge will form, so it will be option number B with plus 6, okay. Next, in the conversion of Br2 to BrO3, the oxidation number of bromine changes from. So in Br2 it is 0, right? So we can eliminate these two options because we have only 2 options with 0. Now if you 3 BrO3 minus, it is plus 5 here. So I can calculate you and show you. So Br, let it be x, oxygen is minus 2 into 3, so it is minus 6 is equal to minus 1. So x is equal to plus 5, okay. So that is option number A. Next, the oxidation number of oxygen is minus 1 in. So now if you see here NO2, okay, the oxidation state here of oxygen is minus 2, here also it is minus 2, here also it is minus 2. But in Na2O2, the structure is like this, okay. So it is a peroxide linkage, okay. So in peroxide it is minus 1, so that is why option number C is the correct answer here. The oxidation state of chromium in potassium chromate. So potassium chromate formula is K2CrO4, okay. So you want to calculate the oxidation state, to potassium is plus 1, so 2 into plus 1 plus chromium we have to take x, then oxygen is minus 2 and there are 4 oxygen, so we will get 0, okay. So x is equal to plus 6. Option number D is the correct answer here. Next, this is important question about balancing. MnO4 minus plus S2O3 H2 MnO2 SO4 OH minus A and Y respectively are. So here you should be very careful and you do not have to solve the complete equation. I will be telling you how easily you can solve it. So first you can see I will take half reaction method. So I am taking MnO4 minus giving me MnO2, Okay, so here the charge is +7 and here the charge is +4, right? So 7 to +4 is reduction. Reduction of how many electrons? 3 electrons will be gained here. Now if I balance the oxygen, here there are 4 and here there are 2, so I will make it 2H2O, right? Now to balance the hydrogen, I have to add 4H plus here, right? But you can see OH minus is there, that means it is in the basic medium, so I will add 4 OH minus here, and on the same time I have to add 4 OH minus here. So now if you see that this 4 OH and 4 H plus can become 4 water, right? It can become 4 water. And now this 2 water can come this side. If I subtract here, so 1 second, if I remove this and subtract this side, it will become 2 water, right? So this is for the reduction half of the reaction. Now let us talk about the oxidation part of the reaction, that is S2O3 2 minus, okay, giving you SO4 2 minus, okay. So if you calculate the oxidation state of sulfur here, I think it is +2, okay, and here it is +6, right. Next you seeing here there are 2 sulfur, so you should make it 2 sulfur. Now for 1 sulfur to +2 to +6, it is 4 electrons required. Now if there are 2 sulfur, then it has to be 8 electrons, right. So for oxidation, it is here 8 electrons. Clear? Now what we have to do, we have to balance that. So for that, you should be seeing that we should be multiplying this equation with 8, right? This whole equation should be multiplied with 8 and this whole equation should be multiplied with 3, right? So that means what you need to find A value, right? So what will be the A value? If you are multiplying this one with 8, so A has to be 8, we can eliminate this option. Next, if you see you are multiplying next you have to find Y, right? So you have to multiply Y, means this one SO4 with 3. So 3 into 2, it will be 6. So 8 and 6 will be the correct answer. B will be the final answer for this question. Next question is also similar, balancing MnO4 minus, Mn2 plus, H2C2O4, CO2, H plus and H2. This is in basic acidic medium, right? So we can write the same reaction first. MnO4 minus will giving you Mn2 plus. 2 plus. So here it is +7 to +2. +7 to +2 is we have 5 electrons. Okay. Then 4 H2O is there. So we have to add 4 H2O. Then we have here 8 H plus. Okay. Next, if I see H2C2O4, H2C2O4 to CO2, okay, H2C2O4 to CO2. Next, here the oxidation state is 8 to 6 plus 3, okay, and here it is +4. 2 carbons, I will make it, okay. So now you see for 1 carbon +3 to +4, there is 1 electron change. So this is this is your reduction part and this is oxidation part, right. So 1 electron loss will be there, but we have 2 carbons, so 2 electrons will be required, right. Now if I want to balance the other thing, carbon is balanced, oxygen is balanced, and I need to balance hydrogen. So for that I can add 2 H plus on this side, right. Now to balance the number of electrons, this is 5, right. So this whole equation should be multiplied with 2, right, and this whole equation should be multiplied with 5, right. Now if I write the whole equation, I will get 2 MnO4 minus, okay, plus 10 electrons plus 16 H plus, okay, gives rise to 2 Mn2 plus, okay, plus 8 water, okay. Next 5 you will get here 5 H2C2O4, okay, then we will have 10 CO2, okay, plus 10 electron plus 10 H plus, right. Now what we can do, 10 electron will be cancelled. So now we will, if I just see MnO4 coefficient will be 2, right. So we can see that we have one option with 2. We can eliminate all this. Next let us check H2C2O4, we got 5, so that is why it is 5. Then M is the coefficient of Mn2 plus, so that is again 2, and CO2, right, CO2, that is 10. So correct answer is option number B here, okay. Next, the number of moles of electrons required to reduce 0.2 mole of Cr2O7 2 minus to Cr3 plus. Now see, Cr2O7 2 minus to Cr3 plus. Okay, here the oxidation state is plus 6. Just you can calculate and check, it is plus 6. So now plus 6 to plus 3, that means there is a loss of 3 electrons, right? Sorry, there is a gain of 3 electrons, reduction. Okay, but here you have to be careful. This plus 6 to plus 3 is for 1 chromium, we need 3 electrons, but we have 2 chromium in this reaction. So that means for 2 chromium, it will become 6 electrons. Okay, it will become 6 electrons for 2 chromium. So for 1 mole of Cr2O7, we require 6 Faraday. Okay, for 1 mole, we require how much? 6 Faraday. And then for 0.2 moles it will be 1.2 Faraday. Okay, so that is option number A here. Next, question number 8, 3ClO minus gives ClO minus, Cl minus is an example of. So here if you see the oxidation state of chlorine, that is X minus 2 is equal to minus 1, right? So that is your X will be equal to plus 1. Right, minus 2 to plus 1, yeah, so here it is plus 1, here also it will be plus 1, and here it is minus 1. So from plus 1 to minus 1 it is reduction, so this reaction is an example of reduction reaction. Okay. Next, which quantities are conserved in the oxidation reduction reaction? So in every reaction the mass is conserved, and in oxidation reaction the charge is also conserved, right? So that is why both charge and mass, option number C is the correct answer here. Next, choose the correct statement applicable for the reaction 2H2O, 2F2, HFO2. Water is oxidized to O2. You can see water to O2, removal of hydrogen has taken place, so water is undergoing oxidation. This is the correct statement. F2 is oxidized to HF. In F2 hydrogen is added, that means it is undergoing reduction, so this is wrong. Next, water is reduced to HF, there is no relation here. F2 acts as a reducing agent in the reaction. So if you see F2 to HF, it is undergoing reduction, means it will act as an oxidizing agent. So that is why this statement is also incorrect. Okay. Next, question number 21. The standard reduction potential at 298 Kelvin for the following half cell reactions are given. Which of the following is the strongest reducing agent? So remember, if reduction potential values are given to you, okay, if reduction potential is high, okay, that means it has the tendency to get reduced easily, right? That means what? Tendency to get reduced easily. Okay, now if it's getting reduced easily, okay, that means what? It will behave as a good oxidizing agent, because itself it is undergoing reduction, so it will behave as an oxidizing agent, right? Now the thing is, if this reduction potential is high, then it is behaving as an oxidizing agent. So if you want reducing agent, then what you should check? Elements with low reduction potential. Okay, if it is having low reduction potential, means it doesn't want to get reduced, it will undergo oxidation better and it will behave as a very good oxidizing agent. Okay, so we can see here out of this all, okay, the one which is having the least reduction potential value is minus 0.6, right? This is the least one. So if reduction potential is very low, that means it has the tendency to get oxidized and it can behave as a very good oxidizing agent. So zinc is the correct answer, option number B here. Okay. Next, question number 22. H2O2 reduces MnO4 ion 2. Okay, so MnO4 ion is converted to Mn2 plus. So it is because here it is plus 8. Okay, in presence of H2O2 it gets converted to Mn2 plus. Option number B is the correct answer here. Next, strongest reducing agent among the following. The same thing, the one which the least reduction potential. So you can see here the least reduction potential is minus 2.71. So that is Na plus, and that is option number 1. Correct answer is option number D here. Next, the non-existence of PbI4 and PbBr4 is due to. Now what happens if you see in this Pb, it is in plus 4 state, right? So now the Pb, when we go down the group, okay, +4 state is less stable, +2 state is more stable, right? So Pb +4 immediately gets converted to Pb +2. Pb +4 is not stable. Okay, so then it is undergoing reduction, so it is a very good oxidizing agent. Okay, so that is a highly oxidizing nature of Pb +4 and highly reducing nature of I- and Br- ions. So both of these factors are responsible. Option number D is the correct answer here. Next, which one of the following species do not show disproportionation reaction? So what do you mean by disproportionation reaction? Disproportionation reaction means the same element undergoing oxidation and reduction, right? If same element is going under oxidation, means oxidation number should increase, and reduction means oxidation number should decrease, right? Now if you see the first question, Cl, okay, what is the oxidation? So for chlorine, the least oxidation state is -1 and the least one is -1 and the highest one is +7. Now if you see here, x minus 2 is equal to -1, so I will get x is equal to +1, right? So from +1 it can also increase, it can also decrease, so it can go to disproportionation reaction. But if you see here, it is x plus -8 is equal to -1, so that is x is equal to +7, right? So now if it is +7, so that means the highest oxidation state is already reached, right? So now from here it cannot further oxidize, it can only go under reduction. So that is why this particular species will not show disproportionation reaction. So option number B is the correct answer here. Next, when a zinc rod is kept in a copper nitrate solution, what happens? Zinc rod is placed, okay, in a copper nitrate solution, okay. So what will be the observation? So zinc is deposited on copper. Okay, so I can say you this is zinc rod and this is copper. Copper is deposited on zinc. Zinc is deposited in the beaker. Copper is deposited in the beaker. So now what happens? Zinc has the tendency to undergo oxidation. Okay, so copper nitrate is there. Okay, okay, it's a solution, right? One second. So we will find here copper nitrate solution is there, okay, and we have zinc rod in that, okay. So what will happen? Zinc will come and displace the copper ion from here, and copper ion will be deposited on the rod, okay. So copper is deposited on the zinc. B is the correct answer here, okay. Or we can write copper is deposited in the beaker only, okay. So that will be more probable answer because it is not zinc, it is on the rod, okay. So that is why we can write copper is deposited on the beaker, okay. Zinc will replace, copper will be reduced here. Next, in this reaction Cu2 plus Zn, okay, the reaction is like this: Cu2 plus Zn gives you Cu plus Zn2 plus, okay. The oxidizing agent. So for oxidizing agent is that agent which undergoes reduction, right? So copper undergoes reduction, so that is why it is an oxidizing agent. So option number A is the correct answer here, right? Next, loss of electrons is oxidation. Option number B is the correct answer. Which of the following is true as per the reactivity series? So if you remember, the reactivity series is zinc is more reactive than copper than silver, okay. Option number D is the correct answer. Next, 30, intensity of blue color increases gradually when copper rod is dipped in silver nitrate solution, silver rod is dipped in the copper nitrate solution, zinc rod is dipped in the, so we have the order like this: zinc is more reactive than copper than silver, right? So now you see, if copper rod is dipped in silver nitrate solution, so we have a silver nitrate solution, okay, and you have dipped a copper rod in that, right? So copper can displace silver because it is more reactive, so we will get copper nitrate solution and the solution will be blue in color. So option number A is the correct answer. But let us see the other option. Silver rod is dipped in the copper nitrate solution. So copper nitrate, if it is there, okay, copper nitrate is there and you have silver rod. then silver cannot displace this one, no reaction will take place. Okay, so the blue color will not increase, the intensity of blue color will remain same because copper nitrate is blue in color, it won't increase, right? So that is why this is not the answer. Next, zinc rod is dipped in silver nitrate solution. Same thing here we have now zinc rod, okay, dipped in silver nitrate solution. So zinc can replace silver nitrate, right? We'll get zinc nitrate, but zinc nitrate is not blue in color. That is why this is also not the answer. Copper is there. Next one, copper is there in zinc. Copper rod is dipped in zinc rod solution. Okay, so there is both are rod, so no reaction takes place here. Okay, or if it is zinc nitrate, okay, and if you have copper rod, right, so copper is less reactive than zinc, it cannot displace it, so we won't get copper nitrate here, so no blue color solution. So option number A is the correct answer here. Okay, so students, after analyzing this whole 30 questions, okay, what I can say you is the most important question is your oxidation number. Okay, you need to do more questions on oxidation number, especially when we have examples of peroxides and superoxides. Okay, this is very important. And another important topic that you should prepare is balancing of reactions. Okay, and the third one is your electrode potential, right, the one which we did, strongest reducing agent. Okay, it can be our strongest oxidizing agent, so that all these three topics you need to focus more. Okay, important topics of this chapter. Clear? Okay, fine. So that's all students in this lecture, and we have discussed the top 30 questions of redox reaction. So now we will be in the next class moving towards the very fundamental chapter of organic chemistry, that is organic chemistry, some basic principles and techniques. Okay, so if you are someone who is not having very good fundamental over organic chemistry, please do not worry, you can watch this videos that will be coming on organic chemistry, and I'll be explaining you each and every concept in detail, so that you do not face any issues regarding like understanding the basic fundamental of organic chemistry. Okay, so stay tuned with this channel, and for that you need to subscribe it. Do not forget that, and see you soon in the next class.